With map data established, the exposed silver ore wall becomes the input as controlled cutting equipment advances.
The scanning data confirms high-grade concentration here.
All right, initiating extraction sequence on the marked section.
As drilling continues, the partially completed pattern acts as the input, while sensors and onboard systems monitor.
Verify depth and alignment on channel 3.
Readings are good, within tolerance. The layout is certified.
Confirmed.
The charged boreholes remain the input, as stemming material is introduced to seal each hole from the top.
With stemming complete, the blast pattern becomes the input, as electronic delay detonators are installed and connected in a precise sequence.
The settled ore pile forms the final input of the chapter as residual dust clears and the blast area stabilizes.
The upper structure rotates smoothly toward a waiting haul truck. The bucket positions precisely over the truck bed.
The fully loaded haul truck now acts as the input as the shovel withdraws and clears the loading zone. The loaded haul truck in steady motion becomes the clear input as it advances along a graded mine haul road. A freshly delivered stream of silver-bearing ore drops onto a heavy-duty vibrating grizzly positioned above the primary crusher.
Regulated silver ore fragments now act as the input as they slide from the grizzly into the wide intake of a primary jaw crusher.
The moving conveyor stream remains the input as it passes beneath an automated magnet and monitoring sensors mounted above the belt. The monitored ore stream becomes the input as it reaches a vibrating screen that classes crushed material by size.
The monitored ore stream becomes the input as it reaches a vibrating screen that clashed material by size.
The evenly crushed silver ore stream arriving from primary crushing becomes the clear input as it transfers onto a circuit. The regulated ore feed acts as the input as it enters the feed hopper above a cone crusher, dropping vertically into the crusher. Finely crushed ore exiting the cone crusher becomes the input as it transfers immediately onto a discharge conveyor positioned beneath this.
The moving ore stream serves as the input as it reaches a secondary vibrating screen designed for tighter size control.
Oversized fragments routed from the screen act as the input as they return to the cone crusher through a closed-loop conveyor system. The correctly sized crushed silver ore becomes the final input of the chapter as it exits the secondary crushing circuit on a dedicated transfer conveyor. Regulated ore feed acts as the input as it drops into the rotating ball mill, joining hardened steel grinding media already in motion. The freshly ground slurry becomes the input as it flows from the mill discharge into a sump where mixing maintains homogeneity. Coarse slurry discharged from the hydrocyclone underflow becomes the input as it returns directly to the ball mill for further size reduction. The fine slurry overflowing from the hydrocyclones forms the final input of the chapter as it flows along a dedicated launder toward downstream separation circuits.
Finely ground silver-bearing fluoride arriving from the grinding circuit becomes the clear air input as it enters a large conditioning tank equipped with heavy.
The actively mixed slurry remains the input as liquid chemical collectors are injected directly into the conditioning tank through
The conditioned slurry acts as the input as pH adjustment agents are added to fine-tune the chemical environment within the tank.
The now fully conditioned slurry remains the input as agitation continues to maintain uniform chemistry and
Flow rate remains constant, and particle suspension is perceived during transfer. The slurry now carries fully active.
The fully conditioned silver-bearing slurry enters the flotation cell as the clear input, flowing evenly into a rectangular.
The enriched froth layer becomes the input as rotating paddles and overflow weirs guide the silver-laden foam toward the concentrate discharge lip.
The discharged silver concentrate froth acts as the input as it flows through a launder system toward the next flotation stage. The silver-rich concentrate froth collected from flotation serves as the final input of the chapter as it consolidates into
stones. The distributed slurry remains the input as flocculent solution is injected uniformly into the thickener feed zone.
The flocculated slurry continues as the input as gravity-driven settling becomes dominant throughout the thickener tank.
The clarified liquid at the surface becomes the input as it overflows continuously into peripheral launders surrounding the thickener.
The dense silver concentrate underflow is pumped steadily out of the thickener through heavy-duty piping. The slurry now exhibits
The pressurized slurry acts as the input as it spreads evenly across filter cloth panels mounted within an industrial. As filtration continues, the cake thickness increases uniformly across the filter surface. Remaining liquid is drawn.
The washed filter cake becomes the input as compressed air is introduced through the filter system to displace remaining moisture. The dried filter cake forms the final input as mechanical mechanisms release it from the filter cloth. The solid sheet
The conveyed silver concentrate acts as the input as it drops into the rotating industrial dryer, where internal lifters immediately. The actively tumbling concentrate remains the input as controlled hot airflow passes uniformly through the dryer chamber.
Ingots. The now dried silver concentrate becomes the input as it exits the dryer through a sealed discharge chute.
The verified dry silver concentrate forms the final input of the chapter as it transfers onto a covered conveyor leading toward
The dry silver concentrate arriving from the drying system becomes the clear input as it is discharged into a controlled feed bin within the smelting preparation area.
thickener rakes gently move the dense silver concentrate toward the central underflow discharge point. The slow mechanical motion.
Flux materials are introduced alongside it on a parallel conveyor. Silica and limestone-based fluxes merge with the
The blended furnace feed becomes the input as it passes through a final homogenizing mixer that breaks up any remaining agglomerations.
The homogenized smelting feed acts as the input as it is conveyed toward the furnace charging system through enclosed chutes.
The staged smelting feed becomes the final input of the chapter as furnace charging mechanisms open and allow the mixture to
The partially molten furnace bath remains the input as temperature climbs further and complete liquefaction spreads throughout the charge.
The fully molten furnace contents act as the input as chemical reactions intensify, driving impurities into the slag phase. The molten silver-rich metal becomes the input as the furnace tap hole opens and a bright, fluid stream of the flowing molten silver-rich metal forms the final input of the chapter as it travels smoothly through the launder toward
The stream of molten silver-rich metal arriving from the smelting furnace becomes the clear input as it is directed into a refractory-lined converter vessel.
The reacting molten system undergoes oxidation in a carefully timed sequence. Temperature rises locally.
Oxygen injection is reduced and slag removal operations begin. Slag is carefully skimmed from the surface.
Slag is skimmed carefully from the surface, lifting impurity-rich material away without disturbing the underlying silver-rich.
Into brains. The molten metal settles into a calm, uniform pool, indicating completion of conversion reactions.
The stabilized molten silver-rich metal forms the final input of the chapter as the converter is tapped and a bright stream flows into a dedicated transfer launder.
The molten silver-rich metal arriving from the converting stage becomes the clear input as it is directed into casting.
plurits. The cooled silver anodes act as the input as they are transferred into an electrorefining cell hall and suspended vertically. The energized electro becomes the input as direct current is applied across the anode-cathode system. The migrating silver ions remain the input as they reach the cathode surfaces and begin depositing as pure metallic silver.
Cathodes are lifted from the cells, revealing smooth, reflective silver sheets free of visible defects. Residual electrolyte drains away.
The silver cathode metal acts as the input as it descends into a high-temperature melting furnace lined with refractory material designed for precious metals.
The molten silver bath remains the input as furnace temperature is fine-tuned to achieve optimal fluidity for casting.
The solidifying silver bars form the final input of the chapter as they exit the molds onto a cooling conveyor.
The solidifying silver bars form the final input of the chapter as they exit the molds onto a cooling conveyor.
Newly cast silver ingots exiting the casting conveyor become the clear input as they transition onto an extended.
Each bar is measured individually, confirming mass consistency with production specifications. Compliant bars pass through without interruption. closing transition completes the full ore-to-ingot transformation. The output is finished, certified silver bullion ready for distribution.